Hello and welcome back to Beam College Intermediate Track. I'm Dr. Gary Downey Clark, and I'm here to help walk through a complex ML pipeline in Apache Beam. If you remember from any of the previous sessions, we've talked about how to establish a machine learning model using the Beam Run Inference Transform and Model Handler class. We talked about how to choose models and adapt them to Beam. We took a high-level overview of the pipeline we're using in this course. And last session, we did a deep dive into the first half of that pipeline, the actual Beam code. Now we're on to the second half, and we'll get to run the whole pipeline end to end. So the pipeline, as you remember, takes a phone call that's a fake phone call to a fake bank's help center, transforms the words of that call into a text message, classifies based on the content of that text as to whether this call is about checking your balance or ordering a new debit card. Depending on which of those requests you have, we're sending it to a different machine learning model. In this case, they are not actually fine-tuned models to help you find a replacement for your debit card. They're just random small LLMs that I've taken from Hugging Face just to demonstrate that you can route different keys to different models and how to do that. Finally, the output of those LLMs is text once again, and we're going to transform it using a different model to go from text back to speech, where we'll then save it as audio. And we're focusing on this second half today. So now, to Colab. Okay. So last time we were looking at the output of the classifier step, which is going to give us a string that defines the call type, check balance, get branch hours, etc., as well as the original text, the text of the original phone call. Now we get to probably the most interesting part of this pipeline. And I think this is something that is a great example of Beam ML being tremendously easy and making it easy to do something very, very hard. Here, what we're doing is we're defining all of the models that we're going to use. Now, originally I had 8 different models, but I found the output of some of the models was very poor, essentially random, and sometimes mildly disturbing. So I winnowed down the models I'm using, and so there's more repetition in here than I originally intended. But you can see that in each of these lines, I'm defining a model handler. These are all Hugging Face pipeline model handlers. They're all for LLMs, so they share a lot of arguments. So I establish up top the pipeline arguments that will be applied to all of these model handlers. And it's just a dictionary of the quargs that would go into that pipeline function. So I say the framework should be PyTorch. The max length of the generation should be 90 tokens. I say what the pad token is in my tokenizer. And I say I would only like to return one sequence. Basically, I'm trying to keep this short so that it will not cause my Colab instance to run out of memory. For each of these pipeline model handlers, they're all text generation as their task, and they are different specific models. These are all small-sized, not particularly capable LLMs, but basically chosen for size. I say use the GPU if you have one, and I got a GPU instance, so we can. And I give them each a name to say what they're doing. So that's just kind of a preview. The balance model handler is going to be for checking your balance. the hours model handler for checking the bank's hours, etc. I find just using these meaningful names, again, helps me keep track of what's what when I'm debugging. So here, I've chosen all of my model handlers, all of my different models. Now I need to map them to the keys that will direct different input to these different models. And so this is a fairly simple construct. Use the key model mapping that we include in the base, in the Beam inference. And you just say a set of keys. In this case, I just have one key per each model, and the model handler that it maps to. And it's important that you know the key here is the first element that you're passing from the previous transform. So here the key is the call type, and that's why that's the first element of the classifier output. So we have our per key model handlers mapping, and then we just say the model handler is a keyed model handler, and it takes that mapping of per key model handlers as its input. And basically, once you have that, Beam will take care of all of the rest of the work of directing inputs to the correct model and also loading those models into the GPU, evicting them from the GPU, batching for appropriate models. It's a lot of work that Beam is doing for you here, and you can get the benefit of that work with a very simple specification. So I think this is one of the most powerful things that we have in Apache Beam, and it's one of our most recent features as well. So if you're confused, why isn't this in Beam? I would make sure that you're on the most recent version of Beam. At least I would recommend 2.51, but at least 2.50. So now we've defined our model handler, and we want to do our post-processing as well. This model handler is not going to require any pre-processing because the previous transform is giving it exactly what it needs: a key and the text that it uses as input to the inference. So we do have some post-processing. As these LLMs make their inference, they generate text. They tend to return the full input as well as their continuation. So we're not really so interested in the input. If we were returning this to customers, answering their questions, we wouldn't want to include their full question because they probably remember that they asked that. And it would be strange to have a machine reading back your own words to you in this way. Still, that might be a choice a business would make, but I'm choosing to only return the LLM's generated output without the initial input concatenated to it. So here we have the call type. It's the same key that we've been passing through as element 0. We have the result, the prediction result is in element 1. And first, I've misnamed this. It's not the text from Whisper. This is the text from the LLM. The text from the LLM is the results example. That's the complete text. I'll place that here as well. That's the complete text, including the input text. So that is the full text here. The full reply is the inference. We go 2 layers deep. Like I say, you may have to look at the specific output to figure out where what you want is hiding in that data structure. We want the generated text. And to just get the LLM's response, I'm going to look at the full reply, and I'm going to replace. Oh, sorry, this was the text from Whisper. Never mind. I shouldn't have changed that. That is the text from Whisper. In fact, that's the original call text. So what we're doing is we're replacing the original call text with nothing. We have the inference, which includes the original text at the beginning. Then we replace it with nothing to eliminate it, so that we're left with only the LLM's response. And that is what we want to pass on to our next and final function. Here I also have a log statement where I print out the call type and the LLM's response. This is because I'm using a different model for each call type. And so I can spot check if some of the models give better results than others, or if some give responses that I don't want to share in a Beam College talk. So this is just something that I did for quality control, but I found it useful enough to leave in. So finally, I'm yielding or returning that LLM response. Now, what do I do with the LLM response? Well, I'm going to turn it back into speech. This is our last model in our pipeline. It is a text-to-speech model that we're getting from another Hugging Face pipeline model handler. This one is called the Facebook MMS TTS Eng. TTS is text-to-speech. Eng is their English model. Say we'll use the GPU if we have it. And that the framework is, again, PyTorch. The output of this text-to-speech model, input, of course, is that text we want to turn into speech. But the output of this is audio data. And so we can call, here in Colab, display, and actually play the audio data that comes back and hear the results of our pipeline. So that's the full shebang. Let's look at the actual pipeline code that defines those order of operations. So this is our main method. It's a Beam pipeline, so we get our pipeline construct. This is a very normal way to define a Beam pipeline. If it's something you haven't done much of before in Python, these pipe operators are not very Pythonic. They are more of a kind of shell scripting or C scripting construct. Oh, goodness. Whereby you are piping the output of one function as the input to the next function. Like I say, it's strange. It's not something that is done anywhere else in Python that I know of. Unique to Beam, but that's a Beam stylistic choice, and it looks a little weird, but you get used to it. So we're saying take the pipeline and apply this transform to each element of the pipeline. Fundamental Beam operation. Take each element, do one thing to it, and then pass the results down to the next transform. So first we get the input file names. We're reading from this Google storage bucket. This is where we're getting all the actual original audio data. It's copied from the open source project that I mentioned in the previous lecture. Then we're going to read that input data. So first we get the file names, then we actually get the data out of the files. Then we pass that data, the audio data, to the Whisper speech to text. These are just kind of the human readable names for the stages or transforms. And this is the actual execution, the actual code. So we pass that to run inference using the pipeline handler Whisper. We use the preprocess function, which just says read the file as a WAV file. And the postprocess function, which is going to do our postprocess Whisper method. And the guarantee is all the preprocess functions are executed, if you have many of them, in order, with a stable order, before you do the inference. And all the post-process is also implemented in order after you do the preprocess and the inference. So we've got our post-process from the Whisper, we're emitting text. So we've gotten the text out of the speech, give that to our XGBoost classifier, which has the keyed XGBoost handler. This has the pre-process function to do the vectorization and dimensionality reduction, and the post-process function to translate those numerical labels back into meaningful text labels. Those come into our keyed model handler, the run inference with the model handler that will match the key to the model. So this is actually the fan out, but you don't see the fan out. It just looks like a pipeline. So again, I think that's an interesting and powerful approach here. You extract the results that come out. This is the fan back in from all those models. And then we execute the text-to-speech using our text-to-speech model handler. And we post-process it to actually play the audio. And in fact, I've been running this while speaking. So we can see here is a request for branch hours. And let's see if we can hear what the model has produced.
Well, that was going to be it. I never did no need an amount. I was in a band. I didn't receive any money. I just got used to the things that I had. I never needed anything.
So see, that's vaguely related, probably, to the request. Vaguely related. Here's one for a check balance.
So now I have this balance. I have to use my Social Security card. That's it. Now, but what do you mean? What I am getting, a lot of people know that I can't log on, but for the very first time, they know I pay a bill through Social Security.
See, so these are interesting to me because they're small, not very powerful LLMs, but they're still getting something vaguely related to the call content. And more importantly, though, that shows that our pipeline works. We're actually taking the call input, transforming it to meaningful text, classifying it appropriately, sending it to a model, getting output, and turning that output back into speech. And this whole pipeline is running on a fairly small machine, about 13 gigs of RAM, not even 100 gigs of disk. It's got a T4 GPU, and we can still generate these fairly quickly. It's been running 20 minutes, and I've got about 110 of them done. So it's interesting that you can do this much with this constraint on your resources. Of course, if you can run this with bigger models that are more powerful on a real GPU, you would expect to see stronger and stronger results. Now, back to the slides. So there we've seen the full pipeline in action, seen it running live and actually generating speech output. Next session, our final session for Intermediate Beam College, we'll be talking about expanding this, what you can do using the same pattern for more realistic problems. All right. Thank you all very much, and I'll see you again soon. Goodbye.